Okay, the last thing I want to talk about this lesson is what's called the law of large numbers, which essentially relates the empirical probability with theoretical probability, and is also the reason why the material we'll be covering the rest of the quarter works. A caveat on the empirical approach. One difficulty with the empirical approach is that people often use it without evaluating a sufficient number of occurrences. So if you heard someone say, like, my aunt and uncle got the flu this year and both were over 65, so everyone in that age bracket will probably get the flu, you would know that your friend did not base his assumptions on enough evidence. The law of large numbers states that if our sampling is representative of the population, then the empirical probability from larger samples will tend to be more accurate than probability from smaller samples. And what this graph shows, this is showing the proportion of sevens with two dice. This horizontal line you see right here is 1/6. That's the probability of rolling two dice and having a sum of 7. And what we have is these dots on the left involve small samples. Like this is from one sample, 2 samples, 3 samples, and so on. And as we increase the sample size, you see the dots become less and less ragged and more stable. And these dots are also getting closer and closer to that horizontal line. That is, that if I make my samples large enough, the empirical probability gets closer and closer to the theoretical probability. So this is why statistics done properly works. If we have a large enough sample size and we do things with randomness, larger samples will tend to be more accurate than smaller samples. Now, suppose you flip a coin 100 times and you got 54 heads. What would be the empirical probability? Well, that's 54 successes and 100 rolls, so the empirical probability would be 54 out of 100, which is 0.54. So how does this compare to the theoretical probability? Well, the theoretical would be there's one head out of 2 sides, so the theoretical probability would be 0.5. So 54% is close to the theoretical, but not exact. If I want a better estimate, the best way to make a better estimate is just do a larger sample. Instead of flipping 100 times, flip 200. Or 300 or 400 or so forth. So 1,000 flips will likely be more accurate than 100 flips, for instance.